Welcome to another fun-filled edition of Comet Algebra. This video is for Algebra 2, Chapter 7, Section 4, Products of Radicals. Again, short and sweet for the new information. Only radicals with the same root can be multiplied, and we call this the product property of radicals. So this root has to be the same as this root, and then you can multiply whatever you have underneath them. So let's look at some examples. Square root 6 times square root 8 is square root 48. And of course, just like anything else, you have to simplify, reduce. 48 we know is 16 times 3, so this becomes 4 square root 3. Now, there is an alternative here, an option. Some people prefer to simplify first before they multiply. If you noticed right here that you had a square root of 4 in there, you could take that out and write this as 2 square root 2. And then this would become, if you had square root 6 times 2 square root 2, that would give you 2 square root 12. Well, 12 has a 4 in it. And so that 4 would come out as 2, and then you'd have a couple 2's in front. So you'd still get to the same answer. So it's really your personal preference. If you want to multiply first and then simplify, simplify first and then multiply, and then simplify again, so you choose. So looking at this next example, we have a number in front of each of our radicals, and when you have that, of course, you plain old multiply them. So 2 times 5 is 10. And now I'm not sure what's easier, to multiply 16 times 4 and get a bigger number, or I'm kind of looking at this 16 and I'm seeing that it has an 8 in it. 8 is a perfect cube. I think I'm going to go that route. So 16 is 8 times 2, and let's take that 2 out. So I'm going to rewrite this. And then I would have, I left the first radical the same, third root of 4x squared, times, okay, so this 8 is the perfect cube, so the 2 came out in front. That's where this 2 came from. And then there's a 2x left behind. So I still have my 2 times 5 is 10, but now I'm multiplying this by 2, and now I'm going to go ahead and multiply my third roots. 4x squared times 2x is 8x cubed. Well, that's interesting. 8 is a perfect cube. X cubed is a perfect cube. And of course, you can do the 10 times 2 is 20. The perfect cube of 8 comes out as a 2. And the cube root of x cubed, of course, is x. So my final simplified answer is just 40x out of all that mess. And of course, you could have multiplied here 4 times 16 and gotten a bigger number and then just worked with that. It really is personal preference. All right, now let's look at a new skill here. Well, it's really just a twist on an old skill. The properties of exponents that we've already learned, they can be used to simplify these types of expressions, but only if you have the same base. So we already know that when we're multiplying like bases, we add exponents. So right now, this is not a problem you could do. You can't take 2 times 32 or something weird like that. But we could do this problem if we change them to like bases. And so a clue that always is kind of screaming at you in this problem is look at your little base. This little base is 2. And ask yourself the question, could this other number be also written as a base 2? And if it can, then you can proceed. So the little base, 2 to the 7th, we keep. And of course, 32 can be written as a base 2 number. Keep your times sign. And it can be written as 2 to the 5th. So now I have 2 to the 5th raised to this x power. And I can simplify that a little bit by rewriting this as 2 to the 7th times 2 to the 5x. Now I'm going to stop here a minute and yell at you before you do something that I would yell at you in class for. Some students look at this and think, oh, okay, like bases. I can add exponents. But then they do something that is totally breaking the rules. They will write this. They think that they're supposed to take 2 times 2 and get 4, and then, I don't know, add this. They still add these. And this is completely and totally wrong. We have never done this in the past. When you have had y squared times y to the 5th, have you ever, let's see if I can do this wrong, have you ever multiplied y times y and gotten y squared and then had it to the 7th or something like that? Of course not. You leave this base alone. Here's y squared times, all you do is work with the exponents and you add them. So when we're up here doing this problem, don't multiply 2 times 2 and get 4. This is just the base, and the base does not change. The base has always remained the same in every algebra problem you've ever done since pre-algebra. With like bases, we learned that we added exponents, so I'm just going to write this in standard form and put 5x plus 7, and that is the simplified answer. All right, let's look at a problem like this where we're asked to multiply these, and of course we can't unless we have like bases. So let's convert this square root 3 as a base to a base 3 number, and we learned that the second root is the denominator, so this can be written as 3 to the 1/2. And this, I'm just going to remind you that 9 is 3 squared, so the squared is the numerator, the third is the denominator, so this can also be written as a base 3 number of 3 to the 2/3. So now that you have like bases, now you can multiply them by adding exponents. But before we can add these exponents, of course, we have to write them with common denominators. So I'm going to change them both to 6. So 1/2 is 3/6, and 2/3 is 4/6. So now I can go ahead and multiply these like bases by adding their exponents. Then let's convert this back to radical form, which would be the 6th root of 3 to the 7th. And again, of course, we simplify this. 3 to the 7th, we know there's a perfect 6th root in there, even though I don't know what it is. It's 3 to the 6th times 3. So this perfect 6th root comes out in front. So I'm left with 3 times the 6th root of 3 for my completely simplified answer. All right, that's what you need to have some fun with section 4, and it is totally radical.